Hello everybody, my name is Aaron Chudasma and today I will be giving you a brief explanation, a code explanation of my Arduino code which is currently opening up. It is small but it is still very much required because you really can't have the Arduino server without the LabVIEW client. So both of these work together. So first we'll be actually going through the Arduino server since it's only 53 lines. Actually, maybe even less than that. Who cares? But it is very small. That's the point. So in here we will be including SPI.h, Ethernet.h. These are not header files, and hashtag include means that it's a preprocessor derivative, meaning whatever's in whatever's in this. Sorry. I don't like seeing errors. So by the way, about those preprocessor derivatives, whatever's in these libraries, these files will be instantly kept in this whole program. So if I define a brand new function called multiply and just that, and if I have another .h file multiply.h and then I say include multiply.h, then that multiply function, even though it's in a different file, the the processor will, the compiler and whatever, the compiler and all, they will actually put or keep or allow access to the function even though it's not there. So by the way I really think of it is that it just puts whatever is in this file directly onto this current file when processing, not right now, obviously. So by the way, these two work together for the communication and all that. And here in we include EEPROM and net EEPROM, EEPROM as in E square prom, as most like to call it. So these two are actually used for accessing the predefined values that are directly in the Arduino program. Arduino board itself. And there's a example file called. Okay, here it is. And set manual. So this is what it really does: MAC address, IP address, DNS server, gateway, and all of these. You just have to put this. So this actually writes the default, and you need to change all of these values whenever you need to change it. And by the way, this is the IP address of. Oh, sorry. Client. Okay, no, sorry, forgot. This is the IP address of the Arduino board. This is not the IP address of the client. The IP address of the client really does not matter. The server does not care about the IP address of the client. Only the client cares about the IP address of the server. Yeah. So this is the IP address of this current Arduino board. And the MAC address just has to be defined, though LabVIEW will never be using the MAC address. Yes, so. I think we skipped over this. So define for each. This just does some for each function. If you ever program with C# or you have, if you are a game programmer, you have definitely seen the usage of for each in my C# programs. Yes. So this just there is, if you ever worked with C, then you know that there isn't any for each loop. There is just the for loop, the while loop, and the do while loop. There is not any for each loop. So this I just got for the for each loop because it lets me loop through things much more easily. And I just wanted to try something new anyways. So this I got from the sources. This I got from other sources. Don't want to say which. So this will be used only in 2 places, but those 2 places are still very important. So define is another preprocessor derivative, and this for each function takes an item value and an array. Which array is it? And every time you type down for each, it will replace the for each with this. Really, it really does replace the for each, the whole for each thing. Sorry, every time you type down for each with these two values, it will just replace that with this giant chunk of code. That's what really it does during compiling. So that's what really happens. I have learned a little bit of C as well, so I know about some of this stuff as well. I've also done C before, so I found it a little bit uninteresting. Anyways, here we define a sensor pin array of A0 to A15. A0 to A15. So that's still 16 because it starts at 0 and ends with 15. And these are constants, meaning you cannot say, after defining these, you cannot say delimiter equals something else. You really can't say that because it's illegal code. Just like that. It's not allowed actually because it's a const. Const stands for constant, meaning not changing. Okay? And then we keep a const character of delimiter. This delimiter, what's delimiter? It's only a character, meaning it's just one tiny part of a string. A string, if you have most likely seen my C# programs and all that, you know what a string is very well. A string is just a some value that is filled with characters like this. It actually has something like 65,000 pieces of 65,000 different options of what you want. These, along with the occasional emojis which also occur in strings. I don't know, but yeah, there are those many. So you will have lots and lots of characters. Some might be left for emojis. You know what those are very well. So in here we have the terminator array. So hopefully Arduino likes a terminator, the array initializer, after defining the name of the variable, not right over here, as you know in the other languages in C# pretty much. So here we have 4 characters. Yes, even though you can't see the 4th one, it's invisible. No, it's not invisible, I'm just joking. It's actually the terminator, meaning the end. It's the star with carriage return, meaning it starts back over, it just writes like this, moves it back, and a new line, character return and line feed. So the last one, it is actually the terminator character /0. That's what it really is. It's just /0. It's a terminator. If you ever studied strings in C, or well, I think it's in all the languages, it ends with a terminator character. Yes. So that's a /0, which stands for the first value in the ASCII code. This thing is only 255 because characters are only 255, not more than that. But the strings in C# or most other languages, I feel like are much more have more values and possibilities. They don't give you errors if you type down Hindi values in different characters in them. Arabic, it can accept that, but this thing will not accept Arabic characters or any other languages. it only accepts English characters and some occasional extended to 127 other characters, you know. Okay, so moving on, I think we're stuck. So in the byte, as in you define it, this thing might seem familiar as error codes in C, not anywhere else. These are error codes, error codes and memory locations to be precise, as in some pointer values. I really don't personally don't prefer using pointers as much, but these are used to denote pointers. Yeah, and you don't need to specify how many there are, because this guy will find it out for itself just by looking at, okay, so this is this many solar sign and like that. And in the IP address, 172.24.75, the IP address of this, the IP address of my client, of the Arduino's client, IP address of the client, not sorry, I keep confusing it again and again. IP address of the Arduino, not this laptop or computer. So then we define a new Ethernet server called server. Yeah, it just felt a little bit confusing for me too as well. It just somehow works. It just does. So, and then we put it with the, then we at the port 3348. I kept this 3348 because that's what LabVIEw uses. You have to keep which port LabVIEw uses for Ethernet communications over here, otherwise it just won't work. Okay. Then okay, this is the first instance where we have the for each. So in here, by the way, all of these A0 to A15 are actually integers. Yes, these are integers, as in 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, like so. Up to, in most cases, it's 12 million or 21 million, one of those two. But it's so huge, I really don't remember or want to remember how long they are. In the for each, we have an integer pointer because that's what this guy accepts. So you need to keep an integer pointer here. Yes, it's sort of a rule here. So then we pass in the sensor pin array, this. So to start looping through all of this, and to access the current sensor pin, the current value, you have to do pointer. You have to put this asterisk sensor pin. Asterisk stands for pointer. And then we set it to the pin mode of input. So we set the pin mode of this sensor pin array to an input pin. Then the net EEPROM, we begin the Ethernet, and then we just start listening for the clients. So we initialize this, and then we initialize the Ethernet with the MAC address and the IP. Then we just start listening for clients. So you are the server, so we define an Ethernet server with this value. This is somehow these are somehow constructors in C. I did not learn that. Actually, I just learned C. This is C++. So these are somehow constructors. It would look something like this: Ethernet server equals new server with the Ethernet server with this value. So this seems a little bit weird for those who have worked with other languages, and I'm saying other languages, not C# because I've encountered Python, occasionally Ruby, and many other languages, and they do not look like this. Seriously, they do not look like this. This is the first time I've ever seen any syntax like this. But this is just how it works right now. And it works like this, and it's very short. And then we start listening for clients, and here we just do serial.begin. This is just for testing purposes. I could have commented this out as well. I actually did comment it out until I found out when I transferred it here something went wrong, so I did some changing just for debugging what went wrong and fixed it, hopefully. and when we do serial.begin, we begin a new communication with serial communication with the baud rate of 9600. This is, I guess, the refresh rate. Yeah, the refresh rate. Then we print the line ethernet.local IP. Yeah, that's actually the IP address of this Arduino. Okay. So yeah, we just print it just for debugging purposes again. And then in the void loop function, and here we do in the void setup. If you ever seen any of my C# programs, or this is actually pretty much, I'm just relating it so you can understand. The start function you see in many mono behaviors, you might have seen that. But if for those who do not learn Unity or that language, yes, it's specifically designed for Unity. For those who do not learn it, this is just starts. This setup is when you directly upload it like this. Upload the program to the Arduino server. This will be executed, or you restart the server by pressing a red button on the side. Then this setup gets executed. And in the void loop, if you have ever seen again, it's the update function. It keeps updating at not a fixed rate, but some frame rate, some random frame rate that depends upon the game. But here, this frame rate, or the time this loop is called, is dependent upon the Arduino's speed or the type of the Arduino. I really don't know that. Knob, weight knob. I've seen. I think, yeah, I tried somewhere. That's the shortest amount of time this can take, not more than that. Wait, 1 knob, wait, 2 knob, something like that. I've seen it in the Arduino interface for LabVIEw, if you have something like that. And then we do server.available. We create a new client with the current available client from the server, the client that is currently connected to the server. And then we for each, again, just like this, we start looping through all of these. Anyways, so I feel like there isn't any need for this, but yeah, I don't think there is any need for this. Haven't refactored this in a long time. Anyways, in this for each loop, we do the integer pointer again. A little bit weird, but still, this is how it works. I like for each loops more than for loops, so they're pretty much the same. So then we keep the sensor pin array again, like we did over there, because that's the only array that is meaningful to loop through. Then we get the value to analog read. We will read the analog values from this sensor pin, and we have to say star, so the current value that is pointed to by this pointer. And in the server.print, we do value, and we also print the value to the serial. And here we also print the delimiter, and both in the serial as well. Then we delay something like this much. This delay is also there in over here, or else it just starts overloading. It felt like that. We need some delay one. A 10 milliseconds, by the way. Not microseconds, you only get milliseconds, not seconds. It feels a little bit counterintuitive, but it's milliseconds. Anyways, over here we do a print line, meaning now we do enter, or actually not enter, we end it with, we do a new line with this carriage return and line feed, and then we do a serial.print terminator again in the serial. So yeah, that's pretty much it. That concludes our Arduino code explanation, and yeah, thanks for watching.